Good morning and welcome back to Math 098. So last class we talked about multiplying polynomials. We actually finished the rules of exponents. Good morning, Ethan. We finished rules of exponents, power, product, quotient, negative, zero, all that good stuff. And then we moved into multiplying polynomials. Monomial times a monomial, monomial times binomial, etc., etc. We learned that when we are multiplying polynomials, we just want to distribute, right? You just want to distribute. You want to be very careful in that process as well. You want to keep track of the rules for exponents as you do this. Good morning, Maria. So for instance, if you have x squared times x to the third, well, that's going to be x to the fifth, right? Because you keep the base, add the powers. So we keep this in mind as we progress through multiplying polynomials. And we're going to do the same thing when we divide. Let's finish a couple problems from last class. So we left off on page 11, number 2. We were looking at 8n plus 3 to the second power minus 7n squared minus 11n minus 1. So we're going to break that down. I wanted you all to go through this on your own at home. So you should have already tried this problem on your own at home and are now ready to confirm whether or not your answer is correct. So let's check it out and see how you did. Good morning, Patrick. So the first thing we're going to notice here is that we have 8n plus 3 to the second power. On this same page at the very top, we learned that whenever we have an expression, a binomial, trinomial, whatever it is, you must rewrite first the expression. So 4n minus 7 to the second power became 4n minus 7 times 4n minus 7. Good morning, Kevin. So we're going to do the same thing here, except I'm going to do a little bit of side work. So for our side work, 8n plus 3 to the second power is the same as 8n plus 3 times 8n plus 3. So over here, I'm going to do the math, and then I'll go ahead and write it on the left-hand side under our original problem. So we distribute. 8n times 8n is 64n to the second power. Remember, you keep the base, add the powers, right? 8n times 3 is 24n. 3 times 8n is 24n. And 3 times 3 is 9. Awesome. The next thing we're going to do is we're going to combine like terms. So we get 64n to the second power plus 48n plus 9. So that expression here takes care of the 8n plus 3 squared part of the problem. So I'm going to go ahead and write that underneath the original problem. 64n squared plus 48n plus 9. The next thing I notice is that my expression says 8n plus 3 squared, which we did, minus a trinomial. We learned in the very beginning of this unit, when we are subtracting polynomials, we must distribute that negative 1. So it's a negative times 7n squared, which is negative 7n squared, negative times a negative 11, which is positive 11n, and then negative times a negative 1, which is positive 1. Perfect. At this point, all we have to do is combine like terms. So we have 64n squared minus 7n squared, which is going to give us 57n squared. Next, we have 48n plus 11n, which is going to give us a positive 59n. And then last, we have 9 plus 1, which is going to give us 10. Excellent work, Kayla. Very nice. And that's okay. So one of the things, so Patrick mentioned accidentally multiplying those. I get it. I've seen that. This is why when we started working through these problems, we would identify the indicated operations, right? So for instance, here we were multiplying two polynomials, right? We were applying that power of 2, which means we're multiplying the two polynomials. And then we're subtracting those expressions. So you had your first expression minus the trinomial. So because of this, we want to be really careful to identify that indicated operation. Okay, good morning, Johanna. So those are the steps you'll want to take. And I'm actually really grateful that you made you potentially made that mistake on this problem because you won't do it in the future. I would much rather you make those mistakes here up front than later on, okay? So that was a learning experience, and it's perfect. You did exactly what you were supposed to do, and I love it. Let's turn the page. Let's take a look at one more. This is an opportunity for you to really ensure that you understand the concepts behind everything that's going on here, behind all of the indicated operations. So for this particular problem, we have 3x minus 11 to the second power minus 2 times 13x squared minus 6x plus 5. And I would like you to solve this on your own. Just take a few minutes. I know, Kayla, you've already finished this. Let me just give the rest of the class a couple minutes to catch up. So go ahead and do this problem now. Let's go ahead and check out what we have here. So first things first, let's do a little bit of side work. So we have 3x minus 11 times 3x minus 11. We're going to be very careful with our signs, of course. Let's go ahead and distribute. 3x times 3x is 9x squared. 3x times a negative 11 is negative 33x. Negative 11 times 3x is negative 33x. And then negative 11 times negative 11 is positive 121. So far, so good. Thank you, Ria. We're now going to combine like terms. We have 9x squared minus 66x plus 121. So I'm going to go ahead and write this underneath my original problem now that I've simplified that half of our expression. Next, I notice I have 3x minus 11 squared, done, minus 2 times 13x squared minus 6x plus 5. So this implies I'm going to distribute the negative 2 throughout this second set of parentheses. This is going to give me negative 26x squared, positive 12x, negative 10. We have to be super careful with our signs as we are distributing. So now I have 9x squared minus 26x squared, which is going to give me negative 17x squared, right? We are careful with that sign. I then have negative 66x plus 12x, which is going to give me negative 54x. And then lastly, I have 121, a positive 121 minus 10, and that's going to give me positive 111. So excellent work, all of you, for sharing your answers. That is going to be the finalized solution, okay? So nicely done, Kayla. Nicely done. Beautiful. We're now ready to move into the last section of Unit 6, and that is division of polynomials. So in order to effectively divide a polynomial by a monomial, notice here that I've written polynomial by a monomial. That's because in 098 we're only going to divide by monomials. When you move into your next algebraic section, you're going to find that you're going to divide by binomials, maybe even trinomials. You'll use things like long division or synthetic division, that kind of stuff. So for 098, for our specific class, we're just taking polynomials and dividing them by a single monomial. Now I want you to consider what we learned from the multiplication of polynomials. We learned that if we had a binomial times a binomial, essentially it's 2 times 2, right? So when you multiplied, you'd have your 4 terms, right? And we can do that easily. Like if we had a trinomial times a binomial. So a trinomial times trinomial times a binomial, that's 3 times 2, which is 6. So we'd have a 6-term polynomial, right? Now think division, right? So if you have a trinomial, which is 3 terms, and you divide it by a monomial, which is 1 term, 3 divided by 1 is still 3, right? So when we divide this polynomial by a monomial, we're still going to have the same number of terms as when we started. We should, because we're essentially saying take each of these terms and divide each of those terms by that monomial. That's exactly the process that we're going to take. So I'll show you. Hopefully it makes a lot of sense, but the trickiest part to this is remembering what those exponent rules. When you have when you are applying the quotient rule, you will keep the base, subtract the powers, leave the base with that excess wherever it was heaviest, okay? Keep that in mind. And also keep in mind that you know how to reduce fractions. If you had something like 15 divided by 9 or 15 over 9, wouldn't you divide both numbers by 3 to leave you with 5/3? You would. So we're not going to eliminate any of the rules we've learned so far. We're just going to combine them all to help us to divide polynomials. Check it out. So in order to actually effectively divide a polynomial by a monomial, we're going to rewrite the quotient as the sum or difference of fractions, right? And I'll show you what I mean by that in a second. And then we will reduce each individual fraction. So here's when we divide polynomials, we rewrite, then reduce. Here's how it works. Notice I have in my numerator a binomial, 35x squared minus 10x, divided by a monomial, negative 5x. I'm going to start this off by writing 35x squared over negative 5x, and then minus 10x over negative 5x. Notice how I have rewritten this problem so that each term is being divided by the monomial. Once I have rewritten the problem, I then can look at each fraction and reduce them carefully. The first thing I like to do is I notice that I have a positive divided by a negative. So I'm going to make a note that my resulting fraction better be negative. Next, notice I have 35 over 5. So 35 divided by 5 leaves me with 7. Then I look at my variable bases. I have x squared over x. Remember, this is an x to the first power. So we're going to apply the quotient rule here, which means we're going to keep the base and subtract the powers and leave it where it's heaviest. If I have 2 x's in the numerator and only 1 in the denominator, when I take 1 away from each, I'm going to be left with 1 in the numerator. So that's going to be right up here with the negative 7. Next, I take care of the signs again. So we have negative divided by a negative. Well, that's going to give me a positive, right? And I'm going to put a little note here. Take care of signs first. And then step 2, simplify numerical bases. And then step 3, simplify variable bases. Okay, and I want you to think quotient rule. All right, I'm hopeful that those steps written out that way will be helpful to you. So negative divided by a negative is a positive. Next, I have a 10 in the numerator and a 5 in the denominator. 10 divided by 5 is simply 2. Notice my x to the first power over x to the first power. So these will divide out and it leaves you with a 1. So 2 times 1 is simply 2. So your final answer is a negative 7x plus 2. Excellent. Let's take a look at the next problem. It says perform the indicated operation. We are going to go through the same process. Remember, rewrite, then reduce. Rewrite, then reduce. Notice I have a trinomial divided by a monomial. Actually, let me go back to our example here. You see how I had a binomial divided by a monomial? So 2 terms divided by 1? Well, 2 divided by 1 is still 2. We have a binomial. So when we do this math, we better have a trinomial. Think of it as 3 divided by 1 is 3. So we should have 3 terms. Okay. We're going to take each term in my numerator and write them each over the monomial, the term in the denominator. Negative 14m to the 8th over 7m to the 3rd plus 7m to the 3rd over 7m to the 3rd minus 21m over 7m to the 3rd. Okay, that is our first step. Take each term in the numerator and write each of them over the term in the denominator, our monomial. Now we just get to apply all of our rules. So let's start with the first fraction. Take care of signs first. A negative divided by a positive is a negative. Notice here, 14 divided by 7, well, that could be simplified. That becomes a 2. M to the 8th over m to the 3rd, keep the base, subtract the power. So if we take 3 of these away and take 3 of them from here, you're left with 5 in the numerator. So negative 2 m to the 5th. For my second term, I have a positive divided by a positive, which is still positive. Notice 7 divided by 7 is 1. And also notice that m to the 3rd divided by m to the 3rd is also 1. So this cancels, leaving you with 1. Perfect. A negative divided by a positive is a negative. And then let's simplify. We have 21 over 7, which leaves us with 3. And then notice we have an m to the 1st in the numerator, but m to the 3rd in the denominator. So when we apply the quotient rule, we see that this m goes away, leaving us with 2 m's in the denominator. And that is our solution. Notice that it is okay for us to have a fraction in our solution. That's totally fine. It just happened to end up this way because the degree in our denominator was larger than the degree in our numerator for our last term. Good. Also notice we had 3 terms divided by 1 term, which meant we should have 3 terms. 1, 2, 3. Perfect. Turn the page. Your turn. Try number 2. So for number 2 we have 9x to the 3rd minus 15x squared plus 7x minus 11, all divided by negative 21x squared. Let's see what you get. Take a few minutes starting now. All right, let's check it out. So we are going to first rewrite 9x to the 3rd over negative 21x squared minus 15x squared over negative 21x squared plus 7x over negative 21x squared, and lastly, minus 11 over negative 21x squared. All right, so hopefully everybody had this exact same first step. Positive divided by negative is a negative. 9 over 21. So notice here that we are not going to get a whole number, duh, right? It's 9 over 21. But we can actually divide both of these by a 3. So if I divide 9 by 3, I get 3. And if we divide 21 by 3, we get 7. So far I have 3 over 7 here. Then I have x to the 3rd over x squared, which means I'm going to be left with x to the 1st power in the numerator. So there is my first fraction. Negative 3x over 7. Next term, negative divided by negative is a positive. 15 over 21. So we're going to do the same thing. Let's divide both of these numerical bases by a 3. That's going to leave us with 5 over 7. Also notice my x squareds are going to end up dividing out. So those will be gone. Essentially, it's x squared divided by x squared is 1. And 1 times 5/7 stays 5/7. Positive divided by negative is a negative. Same thing here, 7 over 21. We can actually divide both by 7. If I divide both by 7, I've got 1 over 3. And then notice I have x to the 1st power over x to the 2nd power. So we have to just say where it's heaviest. So notice it's larger in the denominator. I have one more factor in the denominator. So when I cancel out x squareds or divide out, when I divide out x to the 1st power, I'm left with x to the 1st in the denominator because that's where it was heaviest. And then last, negative divided by negative is a positive. Notice here 11 over 21 actually doesn't reduce. There are no common factors outside of 1. And then also notice the x squared has no other x base to cancel. So our final fraction actually is just going to stay 11 over 21x to the 2nd power. Okay? And that's totally fine. It's not a big deal. If you can't reduce, you can't reduce. What are you going to do? Awesome. In the chat, would you let me know how you did? Did any of you get this solution for your answer? I know it looks really insane, but math is not intended to look pretty, and it's not intended to look compact and awesome, right? To me, this is perfect. This looks great because it's all separated. You have cleaned up each individual term. So awesome. Rhea, Ryan, Patrick. That's fantastic. And this is the section that students will forget how to do later in the semester. Even though we're so close to the end of the semester, I mean, we're in week 11, right? This is the last day of week 11. But this is the topic that some students will forget. Oh, I've got to rewrite, then reduce. So don't forget that when you divide polynomials, you have to rewrite, then reduce. But for those of you who got the exact answer, awesome. That's fantastic. You're already in a good place. Let's do one more problem, and that concludes our notes for the day. Let's check it out. Negative 4m to the fourth n to the second power minus 11m to the third n plus 15m squared minus 13 all over negative m to the eighth n. And you know what? Just because I'm feeling good, let's do this together. Let's go ahead and rewrite first. And make sure you're really careful as you do this. It's too easy to lose a sign or to lose an exponent. So you want to be super, super careful. As we're doing this, did writing out the steps help? Did writing out take care of the signs, simplify numerical basis, simplify variable basis? Did this idea help in your understanding and division of polynomials? Share in the chat your thoughts. Kayla, excellent work. That is fantastic. I love that this is making so much sense to a lot of you, that you're feeling confident enough. Okay, no problem, Kevin. And keep in mind that, you know, stick with us for this first run through of the video. And then what you'll want to do, Kevin, is that later on when you're kind of going through the material again, that's when you can go back to our pre-recorded videos and replay them if you need, okay? So just stick with us, and you'll be just fine. So do that outside of class. Cool. All right, now that I've rewritten the polynomial, let's simplify. Negative times a negative is a positive. My numerical bases, I only have a 4, so the 4 is going to remain in the numerator. I have m to the fourth over m to the eighth. Well, that just means I'm going to have m to the fourth in the denominator. N to the second over n to the first, well, that just means I'm going to have n to the first in the numerator. And that takes care of the first fraction. Yeah, Ryan, I love that you commented about the signs, because that's one of the things that I've seen in my experience get overlooked time and time again. So me personally, I always like cleaning up the signs first. It takes care of that issue, and it's actually a really great habit to get into anyways. So I love that you commented on the signs. Negative times a negative, or negative divided by a negative, is a positive. Notice I only have an 11 here. I don't have another numerical base, so I know 11's in my numerator. Note here that we have m to the third over m to the eighth. Well, that means I'm going to be left with m to the fifth in the denominator. And then also notice that these n's are the same. So n to the first divided by n to the first, they just cancel each other out. They leave you with 1. Next, I have positive divided by a negative. Well, that's just a negative. I have a 15 in the numerator, but I don't have another numerical base in the denominator, which is not an issue. So I just leave 15 up top. Then notice I have m to the second over m to the eighth. Well, there's definitely a lot more m's in my denominator. So if I take 2 away, I'm left with 6 of them in the denominator. Then notice I don't have another n to cancel. So that just means I have n to the first in the denominator as well. And lastly, negative divided by a negative is a positive. And notice that we'll look at each base individually. 13 is my numerical base. There is no other numerical base, so I can't reduce. And then I do not have any m's or n's in my numerator, so I'm essentially going to leave my denominator m to the eighth, n to the first. 4 terms divided by 1 left me with 4 terms. All I did was simplify each fraction. And guess what? That concludes our Unit 6 notes. Okay? We're officially done with Unit 6. For Monday's class, we're going to start week 12 with Unit 7. Unit 7 is all about factoring. So I want you to think about all of the techniques we learned in Unit 6, right? We're putting all of these expressions together, especially with the multiplying and polynomials. What we're going to do in Unit 7 is we're going to break all of that apart, okay? We're going to learn how to factor. I urge you to complete all of the homework pertaining to Unit 6. Complete all of the necessary stuff for Unit 6 now. This weekend, you should be finishing and putting away Unit 6 because you need fresh eyes for Unit 7, all right? Become masters of Unit 6 so that you can take charge into Unit 7 and do really, really, really well, okay? Heed my warning. Trust me when I say this. Find a little bit of time every day. I'm going to be working all weekend long because I've got a lot of grading to do. A ton. So reach out to me if you need any help. On that note, excellent work today. I know we're finishing a little bit early, but that's all we got. So continue to work on your material, and I will see you all on Monday. Have a great weekend. Bye.